Hi there, I hope you guys are doing great. I'm Animesh and welcome to my YouTube channel. This video is the fourth video in the series of the outliers. In the previous videos, we saw how to identify the outliers using graphically, manually, as well as using z-scores and isolation forest. In this video, we are going to deal with the outliers. We are going to treat them programmatically and we'll also do some hands-on. So first we will learn what are the different ways of dealing with the outliers. So let's get started. So the first and foremost way is to impute the outlier values. Once we have identified what are the outliers value in our data set, we are going to impute those values using mean, median or mode. We can also try out using k-NN imputation or regression imputation and also iterative imputation. Those are sklearn packages already available to us. So I have already created video on k-NN imputation, linear regression imputation and iterative imputation. You can check those out. So this is the first method which we can deal with the outliers. Now coming to the second method, we can do the transformation. We can do either the logarithmic transformation, square root or cube root, etc. with our numerical data. But one should be careful while using these types of transformation because transformation can affect the interpretation. Coming to the third method, so this is windsoring or capping, and sometimes it is also called clipping. So this is a method in which we set an upper or a lower limit for the range of the numerical values, and then we keep that value or we impute the outliers with that upper limit value. So I say it in different words that we keep a threshold and we save that value, and then we impute all the outlier value with that threshold value or the upper limit value. So this is how windsoring, capping or clipping is done. We will see this in the demo that will bring more clarity. Now the fourth method is data partitioning. In this method we do the partitioning of the data by a certain criteria. Now what that criteria is, it is basically a threshold, that is the level beyond which the outliers are being identified. That threshold is the threshold on which we are going to segregate our data or separate our data into two parts. One part would be the data without outliers, the other part would be the data with outliers. This also we will see in the hands-on, which will bring more conceptual clarity on this. So let's just jump into the Jupyter notebook. So here you can see I have imported certain libraries like pandas, numpy, matplotlib, seaborn, and I have imported also the Titanic dataset, and I have just removed the NA values in it. And just to get started, let's just see a scatter plot between the age and the fair, just to see our data whether how many outliers are there in the bivariate scatter plot. So I see that there are some outliers in the fair, and also in the age we can see some outliers. So let's just take only one variable for now, that is fair variable, and what we are going to do is just see some outliers and then we are going to treat the outliers. So I'll just plot a distribution plot and let's see how it looks. So we see that it is right skewed, and here we see there are certain outliers which are having value around $500. So now let us see one more plot, which is a very widely used plot in the industry for visualizing the outliers, which is box plot. And we see that the most of the values are in the range between 150 to say 40. Here we see the outlier which is around 500. So we can see visually that there are outliers in fair column. So now what we are going to do is we are going to treat this outlier. So I am assuming that we take the threshold as the interquartile range into 1.5 times plus the median. So that method of outlier detection we will be using. So I have created a function for you to make it more simpler, that we will first do the identification based on some threshold, and then we are going to impute the values according to our needs. So first I have created an outlier impute function where I am going to pass certain parameters like data, column, and the type of imputation that we are going to do. We are going to create the function for this also, but for now I'm just getting the median value, I am getting the for first quartile value, the third quartile value, and the difference between the third quartile and the first quartile, which is nothing but the interquartile range. Okay, and I'm just going to sum median with 1.5 times the interquartile range. Now this will be my upper limit, the threshold value, beyond which I am considering all the points as the outlier, and below that are inliers. Okay, so then I'm going to create one more function which is imputer, where I'm going to pass certain parameters to get the imputed value, and then I'm going to use this impute function value instead of x in case if x is greater than threshold. Otherwise the value should remain as x, because I'm using lambda function here and I'm applying it at the respective column, which is nothing but the fair column in our case. We will see how we are going to execute it. So now let's just go to the function which will be the imputer function. So I have created one more function for you, so it will be easier so that we can just compute the values. So I'm going to pass these particular type of arguments like data, the column, and the type of function that we want to impute. Like we want to impute mean, so type is mean, then it will give me the mean values. If it's median, then median values. If it's mode, then mode values. And if I pass capping, then it will give me the upper capping limit, and it will impute the value with that imputer function returned value. So this is how these two functions are going to interact and work for us to deal with the outlier. So let's just execute it. So what I'm going to do is I'm just going to call the outlier impute function, and I'm passing the data, the column, and I'm going to use the capping method, say for example. So let's just execute this, and now let's just see a distribution plot first. So yeah, so we see that it has imputed the outlier with the upper limit, the capping limit, and now we don't see any value which is somewhere around 500 that we saw earlier. We can also see the same using a box plot. So let's just plot the box plot here, and we also see it's quite now clean without any outlier. So if we want to execute the same function with say for example with mean, so let's change this with mean, and I'm going to re-execute it. But since it's already executed earlier, I have to rerun it. So what I'm going to do is I'm going to just rerun all this, and let's just see. So, okay, so we have executed with mean, and let's now just see the graph. Okay, it's a bit different, but we see that outlier is removed, but there is some point which is somewhere around 200 which is still there. So as the new data is created, but there can be an outlier because of the way we are dealing with the outlier. If I have changed it with say median, and then if I execute it, then that outlier is gone actually. So it all depends upon the way we are going to transform our data or recreate our data or clean the data. Okay, so now that we know the imputation method of dealing with the outlier, let's just do the transformation method. So we are going to do the logarithmic transformation. Okay, so first I just create another copy of the data, and what I'm going to do is I'm going to transform the fair column, all the values, into the logarithmic values. Okay, so before I execute this, let me just rerun the data frame, because there might be some changes already that we have done, so that might affect. So yeah, so let's just execute this, and now we have transformed our fair column into a logarithmic transformation. And then let's just see using a box plot, and we see it has got transformed and we do not see any outlier in it. So it's also one of the ways to deal with the outlier, but as I mentioned earlier, this method should be used with utmost caution, because this might affect the interpretability as well as it might affect your machine learning model. So there are some pros and cons. Now moving forward, we will be doing the outlier partitioning. Now this function I have created for you, which will be easier for us to do this. So what I am going to do is I'm just going to create a threshold for identification of the outlier, and then I am just going to create two data frames, one which is having values less than the threshold. So these values will be the part of the data that does not have the outlier, that is without outlier, and another data would be with outlier, which will be having the column values greater than the threshold. Okay, now this threshold is the interquartile range method way of identifying the threshold. Okay, now I'll just execute this, and then I'll just call this function, and I'll just get these data frame using unpacking of the tuple, and then I'm just going to create a box plot. So let's just create a box plot for without an outlier, and you see it's quite clean now. There's only one data point that we see, which is somewhere near 175. Now let's just create one distribution plot for this, and we can see this distribution plot for the data without the outlier, and it is also looking quite clean and slightly bimodal, but it is looking kind of normally distributed in the real world scenario. And now what we are going to see is we are going to just plot for the data that is having with outlier, and we are going to plot the box plot for that, and we see there is an outlier in the dataset with the outlier. So you see the data is already skewed, and this was expected, and we can plot the distribution plot also for the same, and this is also would be looking skewed, I guess. Yeah, so there are certain data points that we see which is way far from the normal data point. So these are some of the methods which are widely used in the industry, and just dropping the outliers is not one of the best options considered, because we will be losing a lot of valuable information because data is expensive. So that's all in this video. I hope you guys like this video. Please do subscribe to my channel. I'll see you in the next video. Till then, bye bye.